Hello everyone, welcome to the fifth video of this series where we are solving all the past years JEE Advanced question for past 20 years for the topic kinematics. Okay, so this question was asked in JEE Advanced 2023 and this was multiple correct type question. So out of the 4 options, 4 could be the correct, 3 could be correct, 2 or 1. Okay, so we have to be aware, we should not skip one of the option if it is correct. Okay, so let's go through the question, and the size of image was quite larger. I just took a screenshot and copy pasted in my app. So let's try to solve it here only. Okay, so okay guys, you can go through the question. I can make my video a little smaller. Okay, cool. So a slide with frictionless curved surface which becomes horizontal at its lower end is fixed on the terrace of the building height 3h from the ground as shown in the figure. A spherical ball of mass m is released on the slide from rest at height h from the top of the terrace. The ball leaves the slide with velocity mu naught. Okay, with this velocity, the ball released with this velocity and falls on the ground at distance d, here the ball falls. So it started sliding down from this point and then it left the tower at this point and it falls at this point. Okay, falls on the ground from the making an angle theta with the horizontal. Okay, while reaching to the ground it was making an angle theta. Okay, so ball was falling like this, while hitting the ground it was making an angle theta. This is given. Okay, let me erase that because it will just take our unnecessary space. It bounces off with velocity v, and reaches a maximum height h1. Okay, this is the maximum height h1 it reaches. So after bouncing back, it will follow the projectile, right? So it will follow the projectile. It will fall like this and then it will follow another projectile. Okay, so maximum height is given, which is h1. Okay, the acceleration due to gravity is g. Okay, the acceleration due to gravity is g, and the coefficient of restitution of the ground is 1 by root 3. Which of the following statements are correct? Okay, so coefficient of restitution, if I remember it correctly, coefficient of restitution is velocity of separation upon velocity of approach. Okay, velocity of separation by velocity of approach. This is known as coefficient of restitution. Okay, so suppose before collision, so two objects will only collide if they will approach each other. Okay, so before collision the velocity of approach, and after collision if they are getting separated, so velocity of separation divided by velocity of approach, that ratio is given as 1 by root 3. Okay, so cool. So the collision is happening over here. Okay, so ball started falling here and at this point ball was approaching ground, and after collision it started moving back in this side. So this is separation, this is approach. Okay, so before collision there is approach, after collision there is separation. Okay, now I am erasing my unnecessary drawing and let's try to utilize the minimum space which we have and try to solve the question. So what it is given, u is equal to root first option. Okay, first option, what is first option? U naught is velocity, is root 2gh x cap. X cap means in this direction. Okay, velocity is in this direction, so I am happy with this. Let's check about the magnitude. Okay, so what we can do simple. Ball started from here. Okay, at height h, sorry, this is the height h, sorry, ball started from this point. Okay, ball started from this point. Let me erase this. Ball started from this point and it follows this. So can we just apply energy conservation here? Okay, so at this point energy was, potential energy was mgh, and at this point, suppose this is my uh, reference 0. Okay, this is my reference 0 right now for solving just A part. So here potential energy is 0, so here potential energy will be mgh, and at this point, so I am conserving energy between point 1 and point 2. So mgh should be equals to half m u naught square. At this point there is only kinetic energy because my reference is this level, so potential energy will be 0. mgh should be equal to half mu naught square. Why I am conserving energy? Because this is frictionless. This is frictionless. Since this is frictionless, there will be no energy loss. Okay, so since it was frictionless, there is no energy loss, and mgh equal to half mu naught square, and if we will do u naught is equals to root 2gh. Is it root 2gh? Yes. So option A is correct. Okay. Now let's see what is v. V was the velocity after collision. After collision, so we cannot jump directly here. We will see what will be the velocity here and use coefficient of restitution. Let's go to option C. Theta is equals to 60 degree. Okay, theta is equals to 60 degree. What was theta? It was the ball leaves slide and falls on the ground, making an angle theta with the horizontal. Before collision, what was the velocity? Okay, so this was the theta, the direction velocity was making with an x-axis. So can we say suppose velocity at this point was this. Before collision, velocity was this. Okay, so I am taking that as a u. Okay, this is u naught. After collision it is v, so to avoid the confusion I am saying it is u. So there must be two component, ux and uy, right? ux and uy. So we have to figure out, and it is given that theta, what was theta? Theta was this. Theta was this. This is given as theta. Okay, so ball was falling like this, and this was the u, direction of velocity, and angle it is making was 60 degree. If this is 60, this will be 60. Okay, so if this is 60, just by normal trigonometry, can we say tan 60, sorry, this was theta. Okay, we have to verify whether that angle was 60 or not. So tan theta is uy by ux. Tan theta is uy by ux. If this turns out to be root 3, we can say theta was 60. So we have to figure out velocity in the vertical direction and the velocity in the horizontal direction basically. Okay, so let's see. This is 0.3. Suppose this is 0.3, and actually we can say 3 minus. What do I mean by 3 minus? Just before collision. Okay, so from point 2 to point 3, if I draw free body diagram, there was only force in the vertical direction. There was no force in the horizontal direction. Since there was no force in the horizontal direction, there are no reason that there should be change in velocity in the horizontal direction. So whatever was the velocity in horizontal direction, that should be continued. Okay, so velocity in the horizontal direction will be u naught only. Okay, velocity in the horizontal, ux will be equals to, what was ux? Ux was the velocity in the horizontal direction. Ux will be u naught, which is nothing but root 2gh. Okay, now let's see what is uy. Okay, what is uy? So uy, if I see this distance was 3h. Okay, and if I just, and initial velocity in this direction was 0 because it was completely horizontal. Initial velocity in this direction was 0, height is 3h. So after traveling 3h distance, and acceleration is g, force is mg, so acceleration will be g. If I simply do v square minus u square equal to 2as, why I can do this? Because there is a uniform acceleration, that is g. Since u, let me write it very carefully because students can get confused. I am talking about the vertical motion between point 2 and point 3. v square minus u square equal to 2as. What was u? Initial velocity in the vertical direction, which was 0 in this, okay, and v is final velocity in the vertical direction, which is uy, okay. So this is 0, and if I do this, so uy square is equal to 2as. A is acceleration, displacement is 3h, so v is equals to, vy is equals to root 6 gh, root 6 gh, okay. And what was velocity in horizontal direction? I think, okay, velocity in horizontal direction root 6 gh, and velocity in y direction is equal to root 6 gh, okay. In horizontal it was root 2 gh. So what is the ratio of uy by ux? Uy by ux is root 3. Uy by ux is root 3, root 6 by root 2, which is root 3. So tan theta is root 3. It means theta could be 60 degree. Theta must be 60 degree. Okay. So theta is 60 degree. So option C is also correct. Okay. Why I skipped option B? Because it is after the collision. So we will come back to option B. Okay. Now we have to figure out D by H1. H1 is again after collision. H1 is again after collision. So we have to now solve this. Okay. So let's see what I'm just taking the result. Vy is root 6 gh and ux is root 2 gh. Okay. So let's see what will happen after the collision. Okay. Let's see what will happen after the collision. Let's erase all this, and we are just keeping the important information with us. The important information was that before collision, velocity in horizontal direction was root 2 gh and velocity in vertical direction was root 6 gh. Okay. Now what was given? It was given that coefficient of restitution is 1 by root 3. What do we mean by coefficient of restitution? As I told you guys earlier, velocity of separation by velocity of approach. Okay. So here what kind of collision is happening? Ball is reaching at ground and then going back, bouncing back. Okay. So there are two components of the velocity, one in vertical direction and one in horizontal direction. If I will see from the ground, from this point, only vertical component is contributing towards the velocity of approach. Okay. Horizontal component is not helping us to approach towards the ground. Collision is happening here. Which component is dealing with that? Vertical component. Okay. So velocity of approach is vertical component, not horizontal component. So velocity of approach will be root 6 gh, vertical component, which is root 6 gh. Okay. So coefficient of restitution is v separation by v approach. Okay. And v approach is root 6 gh. So velocity of separation will be root 2 gh. Okay. So now again, what is velocity of separation? Horizontal component will remain as it is, because horizontal component is not contributing neither towards approach nor towards separation. So again, velocity of separation is vertical component. After collision, ball will have two velocities, one in horizontal direction and one in vertical direction. Okay. So which component is contributing towards separation? Again vertical. So vy we figured out, which will be root 2 gh. How we figured it out? By using velocity of separation by velocity of approach as coefficient of restitution. So velocity of separation is vy, which is root 2 gh. Horizontal component will remain as it is, which was root 2 gh again. So now post collision velocity in vertical direction will be root 2 gh, velocity in horizontal direction will be root 2 gh. So basically 45 degree, because horizontal and vertical component is same. So we can say We can safely assume that this is 45 degree. So now what we have to do? Okay, velocity. Option B was giving us velocity in two component. Okay, root 2gh is right, magnitude is right. One is showing x cap. X cap is this. Okay, so this is right, root 2gh in horizontal direction. What was minus z cap? Minus z cap. Why minus z cap? Are they saying that z is in this direction? This is positive dash. This is positive z. Is it written somewhere? How I can say this is positive or negative? Where is z? Okay, right. So z is in this direction. Positive is this. This is positive. What was v? V was velocity in a velocity post collision, and velocity has two components. One is positive x, one positive z. So both are positive. Okay, and here one is negative. So option B is incorrect. Option B is incorrect. It should be x cap plus z cap. Okay, so option B is incorrect. Now let's go to option D. Option D. What was D? Option D was d by h1. What was d? D. Am I using d anywhere? I am not using d anywhere. Okay, let's see what was h1. H1 is the maximum height. How do we figure out the maximum height? At max, how do we figure out the maximum height? So at maximum height, vertical velocity is 0. So if I write Vy equal to Uy minus at at vertical height, vertical velocity is 0. So time is equals to Uy by a, and we will put back this value of a. Okay, v square minus u. Okay, we can simply apply the normal formula. Okay, so just keeping the vertical motion in our in consideration, we can write v square minus u square is equal to 2as for all the uniform acceleration. In this projectile as well, acceleration will be minus g, so minus 2g into h1, where h1 is the maximum height. Final velocity will be 0 in the vertical direction. In the vertical direction, final velocity will be 0 at the topmost point. Okay, why? Because if vertical direction will not be 0, they will go further above. Okay, so vertical velocity will be 0. Initial velocity was root 2gh, so u square will be 2gh. So h1 will be nothing but h. Okay, 2g se 2g cancel, h1 will be h. So I know that h1 is h. What is d? We have to figure out d. How we can figure out d? We need to figure out the horizontal distance traveled. How much the horizontal distance will be traveled? u0 into time taken. Time taken from reaching from this point to this point. The time taken by a ball to reach from this point to this point, suppose this is t, so horizontal distance will be u0 t, because u0 was the velocity. How we will figure out the time t? Okay, time t. So let's see, vertical distance traveled from point 1 to point 2 was 3h. So 3h, okay, sorry, I should not write directly. If we can write s is equal to ut plus half at square. So the displacement is, since upward direction is positive, displacement is from point 1 to point 2 is in vertical direction. In vertical direction, displacement is minus 3h. Initial velocity was 0 in vertical direction, and acceleration is minus g into t square. So t is root 6h by g. Okay, so time taken by a ball to reach from this point to this point is root 6h by g. So horizontal distance traveled will be u0 into time t. What was u0? u0 was root 2gh. u naught was root 2gh, g से g cancel, it will be root 12h. So d is nothing but root 12h. And what was h1? We figured out h1 somewhere. h1 is h. h1 is h. So d by h1 is nothing but root 12. Root 12 is nothing but 2 root 3, right? So this option is also correct. So A, C, D is correct, B is not correct. Why? Because this is negative sign. If it could have been positive, all the option would have been correct. Okay. So I hope you guys enjoyed the solution, and this was pretty easy. We just have to do the normal calculation and be aware like what are the consideration, like in which direction we are considering it as positive, in which direction we are considering it as negative. This question was very simple. We did energy conservation and we just applied the normal uniform acceleration equation. Okay. See you guys in the next video. Bye.